Now I know these are exactly the same as the last video, but now we're going to take a different approach here. Essentially what we're going to do is we're going to move these vectors. This vector we're going to move to the origin. At least the tail here is going to be at the origin. So now that's going to give us, and when we take this vector and we move it to the center like this, that's called standard position vector. And one nice thing about this now is actually we can represent this vector in more of an algebraic way. So what I mean by that is this vector now becomes the vector 5, 5. So now we put some quantities to this vector. We're able to do that now once we move them to the center this way and put them in standard position form, or standard position as standard position vectors. So I'm going to do the same thing with the other one. I'm going to move that to the center as well. Now I just moved the vector itself over because I didn't want to leave the original one there for that one because it would have been in the way. So now from here I can do addition. But before I do, let me label this vector in its standard position form here. This one here would be 2. Oops, let me do it in the same color. And then the other value is going to be down 1, 2, 3, 4, 5. So it's down 5. So I'll say -5. So that's going to be 5, 5 for the V, and W is going to be 2, -5. So now all I'm going to do here is the same thing. I'm going to add them in the same way, but I want you to see something once I do. So I'm going to use my parallelogram. So then, using my technique here, oops, just going to draw this line across, and that's going to be my new vector with V plus W. And that vector now can be represented as, let's see, 1, 2, 3, 4, 5, 6, 7. So we can see that that's 7 over, and it's 0 in the y direction. So this is going to be 7, 0, which is going to be my vector here. So the nice thing about this just really kind of opens it up for us. Now take a look at if I just knew these vectors, and I'm just going to write them out here and then use this sum. So I'm going to take this here, I'm going to say V. What is my V again? 5, 5. And I'm going to go plus my W, which is 2, -5. And then if I just take this component here and I add it with this component here, what's that going to give me? That's going to give me that 7, isn't it? Nice. So I'm going to get that 7 that way. And then if I take this second component and this second component and then add them, that's going to give me 0. Now, if we look at our answer, just thinking about this thing algebraically and geometrically, we see we get exactly the same thing, which this is a nice thing. Once I move that to the center, which is possible because we have that one definition that says if the vectors are in the same direction with the same magnitude, then they're equal. So by moving this over, that's legal here. So for that reason, we're able to just think about these vectors geometrically now. Now, knowing those vectors for the second one now makes this very easy. No negating my W and in the other direction. We don't have to deal with any of that. Then I would just have my 5, 5 minus, and my W was 2, -5. And then when I add those together, or not add them, excuse me, subtract those together, the first one is going to give me a 3, and then the second one here is going to be a 5 minus a -5. That's really adding there. That's going to give me a 10. So that's going to be 310. And then for the last one, I'm going to take half of V. So that's going to be 1/2 of 5 comma 5 plus my w, which is 2 comma negative 5. And then that's going to be 5 over 2 comma 5 over 2 and plus the 2 here. So I'm going to write that as 4 over 2. And the next one I'm going to write as negative 10 over 2 because I need the same denominators if I'm going to add these together. So that's all I did here was make those so they're the same denominators as the 5/2. So then that's going to result in, and it makes it easy to add then, that's going to be 9/2 for the first one because I have 5/2 and 4/2. So that's going to be 9/2. And then for the second one, I'm going to get negative 5 over 2. So there's our final answer for the third one. So again, didn't even have to think about the graph at all here. That's kind of the beauty of this. It's not so clunky in that sense. So there's our answers for this one. They look very different than the previous video, but the same question. Now, once I'm using this standard position vector idea here, that's where I'm able to really just get my hands on these algebraically and easily add and subtract. Now, just keep in mind, and I hope you caught it if you've never seen vectors before, this first component that we see here is my x value. Oops, I just put a y there. Imagine that. That's going to be an x, and that's going to be my y value. So that point there here would dictate that x and y value. And I would just use these pointy brackets here to represent vector notation. So it's not a point, so I don't use parentheses. So just kind of keep that in mind too. Those are my x and y values. That's why when I counted to the right 2 and down 5 earlier, that's why I ended up with 2 negative 5. Nice simple way to represent vectors.